For 130, we have three balls in overhead view are identical. Balls 2 and 3 touch each other and are aligned perpendicular to the path of the ball. The velocity of ball 1 has a magnitude of 10 meters per second and is directed at the contact point of those balls. After the collision, what are the speeds and directions and the velocities of ball 2, ball 3, and the direction and velocity of ball 1? Hint, with friction absent, each impulse is direct along a line connecting the centers normal to the colliding surfaces. All right, so if we take a look at this, that means since this is the point of contact here, the point of contact here, the force is going to be directed right along there, which means this final velocity should be along that line. I'm going to call this V2 for the velocity of this ball. This one's going to be going this direction. I'm going to call that V3. And this final one, I'm going to guess, just maybe incorrectly, that it's going to keep moving in the same original velocity. I'll call that V1. The question is now how to solve this. One quick note on this one, just to keep it simpler so we don't have three unknowns. Because of symmetry and because these should be identical forces, I'm going to assume that the forces on each one of these is going to be the same and the final velocities V2 and V3 are the same. The angle here is going to be 30 degrees from the horizontal, which means we can actually do a little bit of work. If we break this into, and I got to choose a different color, into its horizontal and vertical components, what do we know has to be true about the sum of the horizontal momentums of each one of these? Well, those along with this have to equal the original momentum of this ball. I'm going to make the masses of each one of these balls small m, just to keep our lives easy. And we can work this out. By the way, there's also vertical components. Those two are going to be equal and opposite. They're going to cancel out. So solving this. Momentum along this axis, if we think about this as the before and after case, beforehand it's just m times v0 equals the final momentum. Well, the light purple ball is going to have momentum m times v1. And looking at the horizontal components of each one of these other two balls are going to be equal to that. Because V2 and V3 are equal to each other, just by intuition, we're going to reduce this so we don't have so many unknowns and just write it this way. Combining these terms together gives us 2 mv20 times cosine 30 plus that equals that. Reducing it by dividing both sides by m gives us that. In an elastic collision, we also know that energy has to be conserved, and here I'm going to do the same thing. Just the original kinetic energy equals the final kinetic energy of each of the three balls. And again, combining these two down to a single term and dividing by mass at the same time gives us these two equations. I'm going to use the TI Inspire solve function, menu 371 at this point, to solve this. Putting in our two equations gives us our two unknowns. Either, in this case I used x and y and I didn't change variables, we get this. V1 is going to be equal to negative v initial time divided by 5, and V2 and V3 are going to be equal to this. Because they gave us the original velocity in this case is going to be 10, we can actually plug in the numbers here and actually get a final answer. So V1 is going to be negative 2 meters per second. What's the negative sign mean? It means I misguessed this one. This purple ball is going to be moving this way at 2 meters per second, not in the direction I drew it. And the other two balls are going to be moving at 4 root 3 meters per second. And you could convert that into a decimal if you want, along those angles, which are going to be both 30 degrees relative to the original. I hope that helps. This is one of the more complex ones. Even though you have three things moving after the collision, because you've got symmetry, it actually makes it just two unknowns, which makes it fairly doable. Conservation of momentum, conservation of kinetic energy. Good luck.